This is the solution to example 9 from notes 2.5. Here we are given a point on a function, let's say the parent function f of x. We don't know the equation for that. And we want to find the transform point on a new function h of x, which is given by some rule. And when we look at the rule, we can see what transformations have occurred to go from f of x to h of x, and then we can transform the point. In example A, we have h of x is equal to f of the quantity x plus 5. So we are replacing x with x plus 5. When we do that, remember everything that we see happening to x is actually going to be the inverse of what we see. So if we have x replaced with x plus 5, we're actually going to be shifting. So the transformation here is left 5, which means we subtract 5 from x. So if we had the point 3, negative 4, it's going to become 3 minus 5, which is negative 2, negative 4. And the next one, in letter B, we have f of x minus 4. Here note the minus 4 is outside the function. Transformations or things outside the function affect y. So f of x minus 4 is a transformation that is shifting down 4, which means numerically we subtract 4 from y. So our point 3, negative 4 now becomes nothing happens to x, 3, and then we have negative 4 minus 4, which will be minus 8. Letter C, we have f of negative 2x. Things inside the function affect x. So the negative is a reflection over the y-axis. So we have two transformations. Reflection over the y-axis. And the 2 is a horizontal shrink by a factor of 1/2, which means we're going to multiply x values by 1/2. Remember, if we multiply x by 2 inside the function, our transformation is actually going to be multiplying x values by 1/2. So reflection over the y-axis means we multiply x by negative 1, and the horizontal shrink means we multiply x by 1/2. We can combine these into one step. I'll do it in 2 steps here. So if we multiply x by negative 1, we get negative 3, negative 4. And then we multiply x by 1/2, we'll get negative 3/2, negative 4. In letter D, we have 4 times f of x plus 3. Both of these factors, or both of these changes, these transformations are outside the function, so they're going to affect y. Remember, when we have multiple transformations, we have to do stretches, shrinks, and reflections, things that multiply before translations, things that add or subtract. So this 4 is a vertical stretch by a factor of 4, and the plus 3 means it's going up 3. So in terms of what we're doing, we're going to multiply y by 4, and then we're going to add 3 to y. So we began with 3, negative 4. That's going to become 3, negative 16. And then when we add 3 to y, remember x is unchanged, we'll have 3, negative 13. In the next example, we have h of x is equal to negative 6 times f of 1/4 x. So let's go ahead and list all the transformations. The negative in front is outside the function. That is going to be, it's going to reflect in the x-axis. And that means we're going to multiply y by negative 1. The 6 is a vertical stretch because it's larger than 1. Vertical stretch by a factor of 6, which means we're going to multiply y by 6. And the 1/4, multiplying x, is horizontal because it affects x. And this is actually a horizontal stretch by a factor of 4. Remember, we have to do the inverse of whatever we see happening to x in our transform function. So that means we're going to multiply x by 4. So let's go ahead and apply those transformations. So we started with the point 3, negative 4. We're going to multiply y by negative 1. So that's going to become 3, comma 4. And then we are going to multiply y by 6. So that'll be 324. And finally, we'll multiply x by 4. So the transform point on h of x is 1224. Okay, letter F has a lot of transformations happening. So let's start listing those. So the 2 out in front is outside the function. That's a vertical stretch by a factor of 2. And then I'm going to take care of this plus 5, which is also outside the function. That's going to affect y. And that means it's shifted up 5. So that means that we will, in terms of y values, we're going to be multiplying by 2 and then adding 5. And then let's look at all the things affecting x. So here we already have the coefficient of x factored out, which is this 1/3. That 1/3 corresponds with a horizontal stretch by a factor of 3, the reciprocal of what we see, or the inverse. So in terms of x values, we're going to be multiplying them by 3. And then this minus 4 inside the function, where we have x minus 4 with the 1/3 factored out, actually gives us the correct shift. So if we have x minus 4, that means the graph is shifted right 4. And that means we're going to add 4 units to x. And remember, we do multiplication before addition, multiplication or division before addition or subtraction. So we began with 3, negative 4. We're going to multiply y by 2. That'll be 3, negative 8. Then we're going to add 5 to y. So that'll become 3, negative 3. And now we're going to focus on the x. So x values are first multiplied by 3. So that's going to become 9, negative 3. And then we're going to add 4 to the x value. So we're going to have 13, negative 3.